Good afternoon, everyone. Now, I welcome Dr. Ranjit Kuriakose, Professor, Central University, Free State, South Africa, for the keynote address.
Thank you very much. I hope I'm audible and visible.
Yes, sir.
Right. Thank you very much for this opportunity. Before I go into my presentation, I'd like to thank the organizers of the conference today. It's a very special occasion for me because firstly, I hail from a town very close to where MBITS is. I come from Unal. So I'm very proud of the fact that I'm able to stay such a long distance away from Kothamangalam, but still be part of this occasion that is being organized by MBITS College. Secondly, I have a very close association with the college in that one of the founders, Professor P.M. George, was my uncle, and I've had a lot of opportunity to spend with him during my formative years. So to actually speak to you from this venue where he has given a lot of his life to, I am very much pleased to be part of this. So in saying that, let's get directly to the presentation that I'll be making today. So I'm just waiting for it to open up. I hope it's opened up now.
Yes, sir.
Right. Thank you. I'm just going to put it into full screen mode. So as rightly introduced, I'm Professor Ranjit Baby Kuriakose. I am going to make a presentation on the role of engineers in achieving sustainable development goals. And I'm looking at it from a smart manufacturing perspective. So this will be the contents for today's discussion. I'll give a brief introduction of the university that I come from, then a brief introduction about myself and the research that I'm doing. Then we'll delve slowly into the sustainable development goals. And I'll focus on sustainable development goal number 9 and how we went about as a university in achieving some of the targets that are set out by the SDG 9 goal. I'll conclude by looking at some of the other SDG projects that we are busy with, and then we can have a discussion if time allows. Right, so I'm based at the Central University of Technology in Free State. It is in Bloemfontein, which is in Central South Africa. This university has 4 faculties and close to 16,000 students. I myself, I'm in the Faculty of Engineering, Built Environment and Information Technology, and in the Department of Electrical, Electronics and Computer Systems. So just to give you a map idea, most of you might be familiar with the bigger cities such as Johannesburg and Cape Town or Durban, but we are from Central South Africa. The town is called Bloemfontein. These are some pictures of the university campus that we have. Myself, I am an associate professor in the department. I specialize in control engineering. I'm also the project leader in the Center for Sustainable Smart Cities, or CSSC as it's called in short. And my research focus is on smart manufacturing and industry innovation. Currently, I'm supervising 1 doctoral student along with 2 master's students as part of my postgraduate supervision. I've completed supervision for 1 doctoral student and 3 master's students. I've got a few publications, mainly in journal articles, as well as some conference attendance. I've been funded by external agencies in an amount close to 45 lakh rupees in Indian terms. And I'm also having international collaborations with Aarhus University in the city of Aarhus in Germany, as well as Aalborg University in Denmark. So that's a bit about me. Now, this is some of the research indices that I am currently possessing. I have given my Google Scholar as well as my LinkedIn profiles in the beginning of this presentation, and I'll share it with the conference organizers, so you can go through them at length. Right. So now coming to the main topic of our discussion, we'll be talking about the Sustainable Development Goals. So these were a set of goals that were adopted in 2015, just to give a brief background, by all 193 United Nations member states. The idea was to ensure that there is sustainability going forward, peace and tranquility among the people. And as part of this, they set out 21 agendas called the Millennium Development Goals. They subsplit that into 17 goals, 169 targets, and 230 indicators. So like I mentioned, the idea is to have an integrated and universal inclusive platform which leaves no one behind. So based on that, we have 17 SDGs. You can see on the screen here that they start from SDG goal number 1, which is to avoid poverty, going all the way up to SDG number 17, which is partnership for the goals. So each of these SDG goals, they are subsplit into targets and implementation means, which are then assessed on an yearly basis to see what is the progress that we are making in this regard. So as of 2023, this is the progress chart for all 17 goals. So if you have a look here, we'll see that the green is an indicator that the goals are on track, while a yellow section shows that they are moderately or severely off track, while a red indicates that there is stagnation or regression as far as the goal achievement is concerned. So if you have a look here, very few of these goals have got a green bar which is exceeding the yellow or the red bar, which means that of the majority of the 17 goals that we currently have, we are in fact struggling to reach forward in those. But luckily, we'll see if you look at goal 9 is among one of the better performing goals. So our focus is going to be on goal 9, which is on building a resilient infrastructure to promote inclusive and sustainable industrialization and foster innovation. So this is the report card for the SDG goal number 9 at a glance. So you can see that like in all other SDG goals, there is also a bit of struggle with the global manufacturing sector slowing down to around 3.3%. This is mainly owing to the COVID-19 pandemic that we entered into, as well as some unrest in the different parts of the world that is slowing down the manufacturing sector. However, there are some indications of how we can actually climb out of the rut that we are in and actually move forward. So if you have a look at this specific section here, which talks to strong growth in 2022, it says that medium to high and high technology industries experienced very strong growth when it comes to manufacturing. And if you couple that with the last statement here, which says that at the present moment, 95% of the world has mobile broadband access, that is 3G or higher access. So when we couple the two together, albeit we are facing some challenges, we'll see that there is a scope for growth and development as far as SDG 9 is concerned. So what are some of the outcome targets of SDG 9? So SDG 9 has got 5 specific targets. The first is to develop sustainable, resilient, and inclusive infrastructures. The second is to promote inclusive and sustainable industrialization. The third is to increase access to financial services and markets. Number 4 is to upgrade all industries and infrastructure for sustainability. And 5 is to enhance research and upgrade industrial technologies. So you'd see that I've highlighted target 9.4 in red here. That is because of these 5 targets, this is the one that me and my team have focused on, right? So we have set out the target. I've explained how the target will be achieved. Then what are the means of implementation of these targets? So 9.A, that is the first target, facilitate sustainable infrastructure development for developing countries. Secondly, support domestic technology development and industrial diversification. And finally, universal access to information and communication technologies. So as a means to implement our target, which is to upgrade all industries and infrastructures for sustainability, we have chosen the universal access to information and communication technology as the implementation means. So now that I've gone through the introduction of what the SDGs are, let us look at how we can achieve a specific SDG. So there are some steps that we formulated. We also looked at documentations from the United Nations with this regard. So the first of these is to think global and act local. Identifying a challenge in our locality, doing an extensive research into how this challenge is tackled globally, then localizing a solution which is most suited for our region or the community or the environment while keeping in mind the cost and effectiveness. Then developing a prototype or a simulation, and finally exploring the market to see if you can get a buy-in. So this is almost like a blueprint that has been proposed, and that one which we abided by to set about achieving the one of the targets in the SDG goals, right? So now we are going to look at how we got into SDG 9 and how we try to implement it from our side. So our idea was to develop a smart water bottling plant. So we worked in parallel with our management faculty, where we did the engineering side of it and they did the financial side of it. So one of the reasons why we went for the water bottling plant is to allow for sustainable water production. Now, the name of our city is Bloemfontein. So fontein in Afrikaans means fountain. So there is a natural spring that is situated on the campus. So the idea here was to use the natural spring water to create a bottling plant. So I'll just run a short video of how the modeling was done. Let me see if I can play. I hope the video is playing. So we were able to list out each of the components that's needed. We did a thorough financial study. So you'll see that there are some stickers next to each of those blocks that shows what is the manufacturing cost for each of those parts. And then we were able to create a 3D model based on the CAD model that we had, so as to visualize how this water bottling plant will look like. So that was the first part of conception. So we went from a CAD model, and then we developed a 3D model, and we did a feasibility study to see if this would indeed be profitable. But since then, we moved on. Then we decided that we will now need to go on to the engineering side of the design. So a part of my doctoral study involved the development of this smart water bottling plant, although my focus was on optimizing the production of the plant itself. So here you'll see how we went about going through the work. So it was a pleasure of mine to listen to quite a few of the presentations that were made during the course of the day. So this is how I went about developing my project, and also then opening avenues for the team members in my group to further their research on. So we did a very thorough literature review. These are some of the papers that were published in that regard. And then we stated our methodology. We did some research analysis. And then once the paper was, I mean, the project was developed, we looked at what are the different ways in which we can extend or develop the project. We will be discussing that at a later stage. But this is a pointer on how we went about doing the engineering side of our work. So then it got to the point where we needed to now start building the unit itself. So our water bottling plant, which will be discussed later by my colleagues as well, consists of a water filling unit, an assembly line, as well as a capping station. So here you'll see the tank. It is a miniature version. So it is a prototype, or an extended prototype, if you want to call it, that we've developed here. So these are the three hardware units that we had and that we integrated together. So the water filling unit and the assembly line are driven by PLCs, while the capping station is run using a Festo arm, which is used to cap the different bottles. So once the physical system was set about, we then went about designing what is known as a digital twin for the very same. So here, what we did was we integrated sensors to the different units. So you'll see that there is a flow rate sensor and an ultrasonic sensor, which is connected to the tank. Then there are IR sensors, which differentiates between the different bottles that we have. And then the data that is collected from this sensor integration unit is then processed on MATLAB. And finally, we use that for monitoring. So we can monitor elements such as the net production time, the efficiency, the cycle time, and also we can monitor if ever there will be bottlenecks or if there will be constraints that will delay a production process if we get to that. So this is the development of the digital twin. So this is just to elaborate on the data collection. So there are some sensors that are connected to the tanks, as well as the flow rate sensor, which is into the water, as well as the IR sensors, which will be able to differentiate between the different bottle sizes. Obviously, 500 ml bottles will be slightly taller than the 330 ml bottles, so there will be a height distinction. This is the data processing, just one element of it, where we're bringing together all the data, and then we were able to then monitor. So this is done on ThinkSpeak, which is a cloud platform. It currently monitors the flow rate, the number of 330 and 500 ml bottles that are being bottled, as well as the amount of water that is left in the tank. So this is all on the cloud and can be monitored at any given time. Right. So this is how the water bottling plant looks as of now. The picture on the top is a larger scale view of it. I have a video here that I want to play that quickly demonstrates how the device will work. So I'm hoping it is playing now. So it reaches the water bottling station, or the filling station, where the water gets filled into the bottle. And from there, it goes to the capping station, which, like I said, is driven using Festo arms, where we programmed it to identify firstly what kind of a bottle it is, and then do a cap adjustment so as to do the capping of the bottle. So as you can clearly see here, this bottle, whoever gets it will feel a bit hard done by, because it seems like the water bottle is not full. But that is engineering, and that is research. There are sometimes that things don't really fit in or work out completely. But that is basically the operation of the plant. Right. So where are we standing at the moment? So we started off by looking at smart manufacturing, angling in on the SDG 9 goal. And at the moment, we have 5 branches that we are using for our study. So the first is what I was focusing on, that is assembly line balancing and optimization. I completed my doctorate in that topic or niche area. Then I have my colleague John Kotzer. Dr. Kotzer is working on human-machine collaboration. She completed her doctoral study in that field. We moved on to machine-to-machine communication. Currently, there is one student who I'm supervising in that regard. Then we go on to digital twin design, where I have 2 of my colleagues as well, Mr. Mokalusi and Ms. Lemfani, who are both presenting later today. They were involved in the digital twin design. In fact, Ms. Lemfani was involved in the digital twin design, but from a smart farming aspect. And Mr. Mokalusi was involved in the technology integration, where he looked at the incorporation of blockchains into the smart water bottling plant. I did see a few papers on blockchain and blockchain inclusion, as well as some on smart farming. So it is very nice to see that there are people who are thinking along very similar lines, although we are separated by distance. So we encourage people to come through and have a conversation, or even engage with us. There is something that we can also learn from you in how you go about your work as well. So this is a general outlay of what we are basically doing. I've also been involved with some other projects within the Center for Smart Sustainable Cities, but a slight focus away from SDG 9. This is on SDG 7, where we developed a solar vehicle, and the solar car participated in a international competition. It's a biannual competition where you'll have to take your solar car and run it from one part of South Africa to the other part. Unfortunately, we weren't able to go a very long distance with a car, because theoretically our work was good, but when it came to the practical work, we saw that there was some things that were lacking. But one of the things with entering competitions of this nature is that you get to learn a lot by looking at what your counterparts are doing all around the world. The Dutch team from Netherlands, they were the winners of this competition. There was also some stiff competition from the Belgians as well as the Japanese. So to rub shoulders with them and to see how they work on these projects gave us a lot of confidence going forward. We are participating in the same competition again in June and July of this year. So we're hoping to incorporate some of the things that we learned from the mistakes that we made last time and see how we can actually go on further. We are also involved with the Euridice project. It is a project that is concurrently run between 3 partner universities in South Africa, as well as 3 partner universities in Europe, one being in Germany, one being in Belgium, and the other one being in Hungary. So the idea here is to give experience to students in the field of renewable energy, especially with focus on solar and wind energy. So there's a lot of exposure that we give there in manufacturing of solar panels, manufacturing of inverters, installation, and the likes of that, so that we equip uh, our students with knowledge of things that will definitely be a huge factor when it comes to our future. So, to conclude, we started off by looking at the Sustainable Development Goals, which were set in 2015. Uh, there are 17 goals and 169 targets. Of that, as of 2023, many of the goals are lagging behind. So, the focus of this keynote address was on the Sustainable Development Goal 9, industry, innovation, and infrastructure. And we focused on how can we upgrade all industries and infrastructures for sustainable growth. Now, we developed, or we showed a blueprint of how this can be done on a very small scale, with the project conceptualization all the way up to the development of the model. And this was done using the example of the smart water bottling plant that we talked about. So that brings me to the end of the keynote. Thank you very much for listening. Thank you for participating as well. If there are any questions, queries, or comments, I would gladly try my best to answer them at this juncture. Thank you.
Hello, sir. Good afternoon. My name is Bose Joseph. I'm working as a professor of practice at MBITS. So happy to hear about your initiatives for a sustainable future. And just one question: what is the capacity of the smart that water bottling plant, and how many people are being employed? So basically, so how much you have saved in terms of the human capital involvement in the daily production?
Okay. So at the present moment, we have a 100-liter tank. So the smart water bottling plant at the present moment is currently designed for mainly research purposes. But we have seen that we can change the size of the tank to go into a mini or medium scale commercial product. So the tank is structured for research purposes. As far as employment or saving of man hours is concerned, I think it's a topic that will be well discussed or better discussed by my colleague, Dr. Kotsa, who will be speaking next. But to put it into perspective, we are looking at two aspects. We are looking to see how best a human being can be used in a smart manufacturing environment. So we are not looking to completely eliminate the human element. We are looking at the Industry 5.0 element. So we are trying to see how best a human being can be involved there. So if what was initially going to be a environment where there were lots of human beings involved, either with the bottling or the capping or the packaging section, we can now do a monitoring of all those remotely. But at the same time, we would rather use the human force more effectively and see how best they fit into the project that we have. I think that will be better discussed by Dr. Kutsa, who will be speaking next. But if I'm not sure if I answered your question, sir.
It's very well answered, sir. Thank you very much.
Thank you.